Hello and welcome back to the lab. Today on the bench we have a customer's AA5001 non-A. Some of the backstory on this unit, for what I know, is a viewer of the channel sent this into the lab for me to take a look at, possibly do some servicing, and I was told it's playing up. And we can see the 5001 and the 501 A are very similar in layout and configuration. I believe both of these are option 1 units, which means they do have the intermodulation measurements. However, there is a very specific difference between the two. This is my AA501. This is my customer's AA5001. And if we take a look at the back, there's an extra port. So one of the differences between the 500 and 5000 units is the 5000 units are GPIB. In this case, because the buttons are hard, it's not completely programmable. They're mechanical switches in the front so you wouldn't be able to change ranges or anything like that, but you could do readings and things like that and automate testing. On this particular unit, they are not compatible with 5000 modules are not compatible with 500 frames. So, I believe from looking at doing a quick glance at the service document, they are very similar internally, just one has GPIB, the other one does not. So, the alignment process is pretty much the same, but I need to verify that. Some of the more advanced modules, especially the 5000 units, do need to talk to them GPIB to do calibration. I do not have GPIB in the lab yet. That's something that's going to be coming. I can't use my test frame on this because my test frame is a 500 frame. So, incoming 3-bay 5000 frame. So I've been waiting on this to get delivered. There's no options on this frame. As typical for the age, we're missing the feet, which is normal. The rails are very broken on the side. Now, this being a 5000 unit, just freshly taken out of the box. Haven't even done a check-in yet on this. There we go. Not in awful condition for its age. I have already started the 3D printer printing some feet for this. I have CAD files already designed up because these use the same feet as the 5006. So I have full rail feet available for this unit. It's a long print. It's a 31-hour print. Takes about a half a roll of filament, but we'll have feet going down the entire rail system. Now on this, it's not as critical because this has vents in the front, so this can sit flat because this bottom shell is not perforated. But we'll get it up off equipment that's underneath it, because I'd like to put this on top of the DMM stack, but they need some room to breathe, so I can't smash this right on top without overheating the multimeters. My thought process here is after I get done with this particular customer's unit, this will probably become my scope cal frame. I'll put the 3 scope calibration plugins in here for working on tech scopes. But it would be very foolish to plug a customer's unit into an unknown power frame that just got delivered. So I have to check and burn in this power frame before I trust it enough to hook up a customer's unit to it. So that's what I'm going to do right now. I've done a couple videos on checking in these frames and getting them ready to go, so I'm not going to bore everybody with that process in this video, but this is going to run at least for tonight on the bench with some load on it. I'm going to test the frame, test all the ports, test the passing elements, both PNP and NPN that are in the frame. Those have a tendency to go bad sometimes, depending on the age of the frame. Look at the power rails and get everything ready to go. So we will get that done, and then we will take a look at this AA5001, which I think is faulty, at least from what I was told. It was playing up before it was sent to me. The absolute first power-ons are where all the excitement happens, and the magic smoke comes out if it does. So, let's give it a whirl. Uh-oh, my power analyzer finally died. But let's take a look. Alright, so we are drawing about 26 watts. I did hear the fan spin up. The fan is blowing quite nicely. So, let's get a power module hooked up. Or no, we'll test the pass elements first. Then I'll get the power module hooked up and see if it'll at least output some power into my load. Okay, and checking the pass elements, everything tested good. I also checked the 8 volt and 25 volt power rails, and they measured spot on and well within spec with each other. I'm having this PS503A dump 300 milliamps into my load because this doesn't have a 4-bay, it doesn't have the high power port. We're stuck at 400 milliamps, so about running at about 75%. So it's pushing 20.2 volts at 300 milliamp into the load. I'll run this for a while, move it. We'll flip the polarity, run that for a while, move it to the next bay, same thing, next bay, same thing. And as long as everything works, we should be good to go. All right, coming off the 3D printer, we have feet. This is the 8th iteration of the design, but two of these go the length of the power supply and sometimes need to be installed with a mallet. So we'll get them installed, and then we'll be ready to start working on the plug-in. Okay, everything is in place. All is good. We'll turn the power monitor on, and we are ready to pop this AA5001 into the power frame, put some signal to it. We'll see what happens. Well, the good news is it came on. So I was told in the beginning that this was kind of playing up and wasn't behaving like it was supposed to. So we'll see if we can't duplicate a fault. Everything looks pretty good already. I did notice from looking at the service manual that the spec of the 5000 version and the 500 version are a bit different, especially in the residual THD and noise. The 5000 unit, even being the newer unit, is about 10x worse than the 500 unit. So with the THD and auto, 003 is our residual, so we are below our residual already, which is fine. We're in auto mode. We are on volts. Got about 10 microvolts of noise. So we have THD. So what we'll do is we'll put this in like so, because I have the 505 grounded, and we'll pop the signal on, give it something to lock into. And that doesn't look half bad. A little high, but not awful. If we A-weight the filter, much better. So it's working. Let's check the level range. 1.6 volts. We're at 0 dBm. So at least sanity checking it is good. We'll do RMS response instead of average response. See what happens. A little bit. See what happens when we let it warm up. We'll see if we can't get it to play up. I'm going to just let it sit here and burn for a little bit. let it get nice and warm. I did talk to the owner of the unit. Their request is they would like me to do a capacitor refresh and an alignment on the 5001, but I also need to talk to him possibly about his power frame maybe playing up a little bit and see what's going on, because when it's here, this one's behaving. So let's see if it has white coat syndrome or if we have a fault we have to chase. Okay, well, the unit's run most of the evening, and it hasn't really played up at all. So I'm going to need to talk to the owner, because I think their power frame might be suspect. But next thing is we're going to tear this down, get into it, do a cap refresh on it, and then we'll put it through an alignment. All right, we have the 5001 out of the power frame. I did speak with the owner of the unit, and he is going to check his power frames, but he would like me to do a capacitor refresh and an alignment on this. So we need to get inside. Pins in the back, screws in the front. I believe there's screws in the bottom, but we may not need to take that out, but we do need to separate the boards and get everything disassembled. So we got to get into the thing. I should mention, as we are tearing into the side of this thing, the static mat is connected and functioning as one would expect the static mat to. Break some cal seals and expose some circuits. Oh, there's more stuff in here than there is in the 500 series version. Okay, some electrolytic capacitors which will need to be replaced. We have a lot of micas and some really good polymer caps that won't need to be. Those are all looking good. We'll want to replace these guys here to do the refresh. Let's see, a couple down there, so definitely that board's going to have to be worked on. See what we have on the other side. Here is our GPIB board. One electrolytic on that. Not a big... not a problem. Very similar to a 500 series so far. Let's pop the top off. This is going to expose lots of the adjustments. Got some Vactrols on there. We have one capacitor, which isn't too much of a problem. This is the connectivity to the GPIB board. No surprise there. Needs to know what the button, that's actually the front interface panel for the buttons. To be perfectly honest, it doesn't look too awful a job to... there is a adjustment pot on the bottom. We're going to need to take the top and bottom of the frame off when I do the alignment and the calibration on this. Not doing this with an extender cable is going to be somewhat of a pain, but not too heinous, because it's going to be the only unit in the frame at that point. But it is what it is. Oh, those are actually labeled. Nice, RMS cal. Okay. So really, it looks like most of the caps are actually on this board on the side. There's a couple of stragglers in the guts that we'll have to uncover, but I don't think it's gonna be too awful. Time to document stuff. Camera, drawings, document everything where it goes. So obviously when we get the unit put back together, everything goes back where it belongs. To get getting the back plate off, I have some micro wrenches that'll take these two pins out, and then the back plate will pop off, and then that'll expose the boards for me to get at them a little easier. It's going to be really documenting where connectors go and things like that to make sure everything gets wired back up right. There's a lot of stuff happening going on everywhere. So lots of pictures, lots of drawings, and we'll proceed. Okay. We're in a state of disassembly at the moment. And this is going to break apart into two main pieces. We're going to have the input meter and GPIB board, and then we're going to have the distortion analysis section that's going to come out. So there's a screw on the bottom, and there's two screws on the side that holds this entire block together. So this is all, once I get all the cables disconnected, which I haven't disconnected anything quite yet, everything's going to come apart. That's not awful. I also don't think I'm going to need to take this board out to service it, because this board has pins on top, and we'll be able to pull this out sideways and get at it, and then this is going to come out as one piece so I can service it. The important part is when this thing moves, I have to make sure all these connectors, I know where they go, especially these two, because these two connectors, one is brown, the other one is orange, but they are very, very close to the same color. Like it's kind of hard to tell them apart. So all right, so orange actually goes to this connector right here. So the bottom connector here goes to top connector here, and brown connector goes to brown connector over here. So that is good to know. And then I think this is going to come off. This will stay. Black to middle black, black to far black, green to green, input connector, which is all the way down to the bottom and a pain to get into, but I'll get that out once I get the boards loose. This is the function outputs, so this will come over here to the front panel. That's an easy one. But I need to draw some of this, some more of this up now that I have this. This is a lot easier to track down now that this section's out. Definitely, if you're doing this, take your time. There's stuff going everywhere in one of these plugins, so take your time, document appropriately to make sure it goes back together on the easy side. Okay, first circuit block is out. This is the hardest connector to get out. It plugs in on the back side. I need to be very careful of these ceramic resistors. It plugs in down here. Getting that out while being careful with these is difficult to say the least. So here's our relays from what I've done. This one actually has 4 and 1 and then another 2-pole instead of a 4-pole. And then there are more relays down here that may need to be replaced and a couple of other things. This unit seems to be doing okay, does not need relays, but if you did need to do relays, these are the range relays. Same as in a 500 series. These boards will separate quite easily from these posts. So the next task is to get this top board off so we can get at the capacitors to replace them. So it'll be these 4 screws, and then the interconnecting pins will just slide off this way and everything will be good. So that'll be pretty easy. Working with these boards isn't terrible. However, I do have to be really careful not to crack these ceramic resistors. That would be a bad day. So we do have a couple of caps on this smaller interface board that we'll need to replace, but we have really good access to that from this on this side. And then there's a couple caps down here that'll need to be replaced, but when this board comes off, we can get at those. So this will not be too bad, but I do need to separate all of this stuff and get this apart. Okay, we've got board number 1 out, and it did come apart relatively easily. This shield stays with the main board due to that screw. So if, yeah, I will need to get some caps from under that shield, so that screw will need to come off. But we can start capacitor replacing on this particular board at the moment. Okay, so we're going to do some of this under N2 because we can. I have it. We might as well use it on a customer piece of equipment. And we have a 10 microfarad by 50 volt. One thing we are going to do is, while the board's like this, I'm going to take some overhead down pictures So I have a cap map and polarities as to which way is which. Okay, well, bad news is I only have one more 10 microfarad by 50 volt capacitor in stock. But the good news is relatively available part. There's the part number if anybody's curious. But I do have some 10 by 100s, which will work just fine, and I have plenty of those in stock. So for wherever was going to have a 10 by 50, it's going to get a 10 by 100, and that will be fine. Okay, here's an instance where you always want to trust what's working before you. Here's an instance where the solder mask is incorrect. The square graphic is usually the positive side. In this case, it's the negative side. The capacitor that was in circuit in this position, the negatives were facing each other on this one. I confirmed that with the photos I took and things like that. So you can't always trust the solder mask. Sometimes it's wrong. What was working before will typically be correct. Okay, I have the recap done on the boards, especially with this board, because there's so many capacitors on it. I put a Sharpie dot on each one of the capacitors so I knew what I had replaced and what I had not replaced. So since there are no Sharpie dots, everything's been replaced. So everything's ready to go back together. I have to start stacking these boards again and then get them back in the unit. I'm going to take a look at the other boards that are back there, see what kind of stuff we have to get into, and then we're going to let it do some burn-in testing before I do the alignment. But relatively straightforward, kind of fiddly, being careful not to crack these ceramic resistors. Just being careful. Lots of 10 microfarad, so everything small was a 10 microfarad capacitor at either 25, 50, or 35 volts. I replaced them all with a 100-volt cap. That's going to be totally fine. Nothing's going to happen there. I'm going to stack these boards back up, get everything put back together, and then we'll address the other side. Okay, by removing the associated screws, you are able to get the GPIB board out. These two connectors have to come off. They are actually 3 connectors, sorry. The front panel connector here, white and brown, have to come off, and then the GPIB board pops out, which also exposes the backside of the voltmeter board for getting this capacitor replaced. So I have to do these two, this one, and then we should be up for testing. And there's the last cap on top of the board, swapped out. So now I have the hard part. I got to put this thing back together. All right, after triple checking all the connections and the polarity of all the capacitors as I was putting everything back together, the unit is pretty much back together and ready for its first power on testing after a complete disassembly and essentially having all the bypassing caps in the power supply swapped out. So let's go ahead, and I have it in THD plus N, auto ranging, and A-weighted filter, same thing as before. And we have it hooked up to an SG505. Let's see if it's lost its mind. Shouldn't have. Everything went well. No smoke. Well, that looks good. See if that comes down a little bit more. There we go. All right. So what we'll do is we'll let this burn in. And, ooh, we got down to 9. A little quieter. We will let this burn in and warm up. And then make sure we don't have any power supply problems, anything like that. So I'm going to let it run again for the rest of the evening. And then it'll be a couple of seconds for you guys. But tomorrow I will really warm up the lab and we'll get into an alignment and calibration. I will have to take the cover side and bottom off of the power frame to get at all the test points, because there is, or adjustment points, because there is quite a few of them. So, but all I got to do is, or all it has to do is sit and run, but making good progress. Okay, so I've got the side panels off. We are ready to start the alignment procedure. I'm going to show some highlights of the alignment procedure. It's not going to be a detailed alignment procedure on this one. The AA5001 calibrates exactly the same as a 501 A. So if you'd like to take a look at the in-depth calibration procedure, take a look at the AA501 A video. We've already covered that in detail. So, but I will hit some of the calibration highlights on this so you guys can see how well this is performing. But here we go. Okay, I was able to tweak it or squeeze a little bit more out of the AA501 when I was getting everything dialed in. This unit has been very close. One least significant digit out on pretty much all the checks, so incredibly close. The last calibration was relatively recent, so nothing bad there. What we've got on the scope here is we have the fundamental coming out of the front end of the 5001, and then we have the post-function jack. This is the notch filter. So this is what's actually left after the notch filter has notched out the fundamental. This is actually what it's reading for the distortions. So essentially what this unit says is throw away the fundamental, everything that's left, that's harmonic distortion. Harmonic distortion plus noise. So using a scope, it really helps to get the notch dialed in right. You can do it with the front panel display, but triggering on, in this case, the fundamental and then removing as much of the fundamental as possible from what's left does make this really easy to dial in. All right, this concludes the alignment on this AA5001. I did sub in my Rigol DG2000 for the function generator for the, what were these? SMPTE and the CCIF cals. It was just easier to dial in the waveform on that and get it ready to go. But we're fully lined up and everything is back to rights. Calibration-wise, this was not very far off. The farthest things that were off were the SMPTE and the CCIF, which are not widely used these days, but they were off by a cal count, or about 10 counts. So all in all, this is a wonderfully maintained unit. Stood the test of time very well and is ready to go for some more. Thanks for stopping by the lab today and taking a look at this 5000 series distortion analyzer. This one is ready to go back to its owner and spread some distortion analysis around their bench. As always, in between videos, I will see everybody in the comments section, and I can always be reached on Patreon and a couple other places. Patreons are running about 4 videos ahead right now, so if you want to get some additional content before it gets released to YouTube, feel free to check that out. As always, videos come from viewer requests and submissions, so if there's something you'd like to see me cover, drop me a line and we'll see what we can make happen. As always, more is on the way.